Okay, so this is the continuation of the previous video. In the previous video, we looked at how to do steps 1 to 3. In this video, we're going to take a look at how to do 4, 5, and 6. So here we are inside GT shell environment, and it's similar to GT menu. So for example, if I wanted to run a dynamic analysis, eigenvalue solution, I can go eigenvalue, frequencies, give the same commands here. But the good thing is it will actually show me the input commands that are going in and also the output, okay? So it's like a debugging mode where you can type in commands, see what the commands are, you can prepare your seed files, copy and paste data into your text input file, okay, and so on. Okay, so the next step is to go in and define the response spectrum. Okay, so for that I have an Excel spreadsheet, and I'm going to basically take the accelerations from this column in the period from this column and copy it to a data file. Okay, so I'm just going to open up a new session of Notepad, file, save as, and just call it RSA response spectrum analysis and today's date, So once I do that, I'm going to save this file, okay? Then what I'm going to do is go to modeling, loads, and dynamics, and click on store response spectrum. And here you can define your damping ratio, which is 0.05. You can click on data file option, click on these three dots, and pick the file that's created. I probably didn't save it in the right location. I'm going to go to save as and save it under my downloads folder and call it .dat. And there's the file. Once that's done, I can just click on read file. So all that data comes in from that data file into the spreadsheet. You can also type in data if you wanted to do that. Then you can just call this file name RSA data, okay? And you can give a factor of 32.2 because this acceleration is in terms of G. So I need to put in a scale factor of 32. Once that's done, you can click on store data and yes, and click on enter, click on yes, and that will create your response spectrum curve inside GT STRUDL, okay? Now you can put in new curves also. That dialog box was asking you for more information, but we can close that dialog box and then proceed to the next step, which is running the response spectrum and defining the response spectrum load direction, okay? Okay, so for that, I'm going to go to modeling, loads, and dynamic response spectrum load. So the response spectrum load is the second load case in this file. I'm going to apply it along the X direction, and this is RSA data, okay? You can click on display response spectrum curve and you can actually see the same curve inside GT STRUDL with the scale factor assigned, okay? We saw it in Excel, but it didn't have the scale factor, right? So this is scaled by 32.2. Once that's done, you can give a description also. Just call it seismic along X direction. Click on OK, and that creates your load command. Now the final step is to run the analysis. So you go to analysis, dynamic analysis, response spectrum, and the response spectrum analysis is done, okay? Now you can also go to results, dynamic analysis results, and compute And you can compute the response spectrum results now. So we can just say I want to do the forces, use all combinations, select members. You can select members graphically, but I'm just going to say all members also here. Click on OK, and that does the computation of the response spectrum results for you. Now you want to see the results, right? So you can go to results, dynamic analysis results, list. And it's asking you if the results have been computed. We'll just say yes. Select the response spectrum, load case for which you want to see the results. And you can pick any of these options. I'm just going to pick forces. Just click on all. Select members, all. Click on OK. And there, those are all your results for the response spectrum analysis. Okay, so that was in a nutshell how to run a response spectrum analysis from scratch. In the next video, we're going to take a look at how this can be incorporated into seed files so that you can run it over and over again. I'm just going to run an example problem that's distributed with GT STRUDL. All these steps are also documented in the PDF document. So you can also take a look at this document for more information.